Good day. In this video, you will learn about the first part of relation.
Our learning outcomes are determine the Cartesian product of given sets, find a relation from a given set, represent the relation using the pictorial representation, and determine the composition of a given relation. The concept of relation was introduced by Augustus de Morgan, and we deal with the relational operators, and these are the less than or equal, less than, greater than equal, not equal, and equal. And these relational operators are commonly used in defining relations. Now, the concept of relations or the use of relations can be found in computer science and many more areas. In our set theory, the concept subset represents the relationship between the two sets. Now let's have Cartesian product. By definition, the Cartesian product of sets A and B, written as this one, A times B, is the set of all ordered pairs AB, where A here is an element of set A and B is an element of B. Hence, A times B is equal to AB such that A is an element of A and B is an element of set B. Now let's have our example. Suppose we are given a set A whose elements are NOE and set B whose elements are 1, 2. Now if we're going to find for the product of A and B, or A times B, then we'll just have to write the elements of A times 1 and 2. Then what we're going to do next is to multiply each element in A to each element in B. So we're going to find out N1, another element would be N2. Next, we have O1, then O2, and we'll have E1, and the last would be E2. So these are the products of A times B. Next, how about if we're going to interchange the position of these two sets, B times A? So again, we have to write the elements of B times elements of A. Then multiply 1 and N, 1 and O, 1 and E. Next, proceed to 2, 2 N, 2 O, then 2 E. So this is the product of B times A. If you notice, they don't have the same product, so that is why we have a fact that A times B is not equal to B times A. Next, how about if we have A times A, or just simply A square? So meaning we have to multiply A by itself. So again, we have to write the elements of A, NOE times NOE. So the same process to the previous two examples. So we just have to multiply NN. So we have N, then N. That's not N square. Okay, that's N and N. Next, NO. Then we'll have NE. Next, ON, OO, OE. Then EN, EO. Lastly, we have E and E. Okay, so this is the product of A times A. So that's all about Cartesian product. How about if we have more than two sets? So we're going to use the product sets in general. So by definition, the Cartesian product of the given sets, okay, and then we'll have this notation. Okay, for you to understand this, let's have this example. Let set A equals ISU, set B 1, 2, set C 5M. Then we're going to find for A times B times C. So all we need to do is to write each element of each set. Okay, then we have to multiply first I with 1 with 5. Okay, so we have I 1 5. Next, I 1 M. The next, we have to proceed with 2, I 2 5. Then we have I 2 M. Okay, the next, going to proceed to S. We'll have S 1 5, then S 1 M. After M, we're going to proceed with 2, S 2 5, S 2 M. Okay, same also with U, U1 5, U1 M, U2 5. Lastly, we have U2M. Okay, so this is the product of the three sets. Now find for B, C, and A. Next, we'll have relation. By definition, a relation R from a set A to set B is a subset of the Cartesian product A and B. This subset is called a binary relation or simply a relation from A to B. Okay, by notation, we have this. We're going to use this notation, meaning A, B is an element of R or the relation, or A is related to B by R. Okay, let's have this example. Given set A NOE and set B 1, 2, is R a relation from A to B? If we have the relation R N1, N2, O1, O2, E1, E2, is this relation a subset of A to B? Now let's check each ordered pair. We have from A to B, so we have, meaning we'll have N first going to 1, so we have N1, so N1 is correct. We have also N2, so we have also N2, O1, we have also O1, O2, E1, and then E2. Since all these ordered pairs are elements of A to B, then it is a relation from A to B. Next, how about N1, O1, and E2? Okay, as you notice, each ordered pairs are also elements of this relation. So we have N1, okay, we have also N1, next O1, and then E2. Okay, so from A to B. So this relation is a relation from A to B. How about this one? N1, O1, O2. Okay, so again, this is a subset of this relation. Okay, so notice we have N1, we have also O1, the next O2, okay, O2. Okay, so since it is from A to B, then it is a relation. Next, how about this one? And let's check each ordered pair. We have 1N. Okay, so 1N, from 1N pa ganun siya. So we have B from B to A. Okay, is this one relation? It's not, because we are looking for a relation from A to B. In this case, 1n is a relation from B to A. So it is not a relation from A to B. Next, how about this? We have again 1n. Okay, so 1n is not a relation from A to B. Okay, but rather it is a relation from B to A. Though n2 and e1 is a relation of or a subset of a relation from A to B, but still there's an ordered pair here which is not a subset of A times B. So it is not a relation from A to B. Next, let's have this practice exercise. Suppose we have set A from 1, 2, 3, 4 and R is a relation in A. Define the relation R on a set A as a set of ordered pairs when first, the relation R expresses greater than on set A. Okay, so meaning the first element in the ordered pair should be greater than the second element using this set. Okay, of course, we have 2, 1. Okay, here 2, 1. Okay, so 2 is greater than 1. Next ordered pair, we have 3, 1. Since 3 is greater than 1. Next, we have also 4, 1. Since 4 is greater than 1. And then so on. So we have 3, 2. Then we have also 4, 2. Then we have 4, 3. Okay? So this is a relation expresses greater than. Okay, on set A. Next, relation R expresses less than on set A. So the opposite of number 1. So since 1 is less than 2, then it is one of the ordered pairs in the relation. Next, we have also 1, 3. 1, 4. 2, 3. We have also 2, 4. Then 3, 4. Okay? Next, how about the relation R expresses equal on set A, meaning they must be the same. Okay, of course, we have 1, 1. We have also 2, 2, 3, 3, and then 4, 4. Lastly, relation R expresses greater than or equal on set A. So all we need to do is to get all the elements of this because this one is greater than. Okay, so we have 2, 1, 3, 1, 4, 1, 3, 2, 4, 2, then 4, 3. Then since it is greater than or equal, we have to get also the elements of this set. Okay, we have 1, 1, 2, 2, 3, 3, and then 4, 4. So this relation expresses greater than or equal on a given set A. Next, composition of relation. Let A, B, and C are sets. R is a relation from A to B. S is a relation from B to C. Okay? Then the composition of R and S denoted by this symbol is a relation from A to C defined by R composed of S is equal to AC such that every element in B is an element of set B for which AB is an element of relation R and BC is an element of relation S. Okay? Let's have this example. Suppose we are given the relation W and X from the set 1, 2, 3. So these are the elements of each relation. We're going to find for X composed of W. So this is what you're going to do. Our point of reference here is first X. Okay, so we just have to look at the elements of the relations of X, then find for B, which is common to W. Then get the first element and the second element of the second relation. So first, I'm going to look at x first because it's written first here. So 3, 3, then we'll have also 3, 2 here. So we're going to get the first element of x and then get the second element for w. So the first ordered pair in this composition is 3 and then 2. Next, we have also 3 here. We have 3, 3 and then 3, 1. So we have 3 and then 1. Next, proceed with this ordered pair. We have 2, 1. So we'll have this 2, 1, 1, 2. Since 1 and 1 is common, then we have to get the first element in x, the second element for w. We have 2, 2. Next, we have also here. Okay, so we have 2 and then 1. Next, proceed with this ordered pair. So we have 3 here. So get 1 and then 2. Next, we have also here. So get 1 and then 1. And lastly, with this ordered pair, we have 1, 2, and also 2, 3. Okay, so that's why we have 1 and then 3. Okay, so that's a composition of relation. Next example, how about W composed of X? And our point of reference here is W. So we're going to look first W before going to X. Next, 3, 2. So find for 2 in X. So we have here. Okay, so the first ordered pair would be 3, 1. Next, we have also 3, 1, 1, 3. So we have 3, 3. Another, since we have 1 here, okay, so we'll have also 3 and 2. Next, 2, 3, 3, 3. So we have 2 and then 3. Next, 1, 2, 2, 1. So get 1 and 1. Next, we have 1, 1, and 1, 3. So get 1 here, the first element in W. The second element for X, so we have 1 and 3. Lastly, we have 1, 1, 1, 2. So get 1 and then 2. So we'll have an ordered pair 1, 2. So that's the composition for WX.
Now let's have our third example. So how about if we have three relations? So for example, W composed of W composed of X. So unahin natin muna yung nasa parentheses. So W composed of W. So tingin natin dito, tignan natin dito. So we have 3, 2. So dapat 2 yung mauna. Then we have 2, 3. So we have 3 and then 3. Next, so since wala nang 2 dito sa my domain, except this one, so let's proceed to the next ordered pair. 3, 1. So ibig sabihin, 1 din yung domain na titignan. So we have 1, 2. So we have 3, 2. Then also here, we have 3, 1. Next, proceed to 2, 3. So we need to see the 3 as the domain. So we have 3, 2. So 2, 3. And then 3, 2. So we have 2, 2. The next 2, 3. Then 3, 1. So we have 2, 1. Next ordered pair, we have 1, 2. So tignan nyo naman yung 2 as the domain. So ito lang yon 2, 3. So we have 1 and then 3. Next, we have also 1, 1, 1. So 1, 1, 1, 2. So that's why we have 1, 2. So yan. Next, we have also 1, 1. Why? Because 1, 1 is the same with 1, 1. So sa sarili niya. Okay, so we have 1, 1 here. And then, compose of x. So, kunin natin yun. Ngayon naman, gamit itong relation na to, newly formed relation, titignan naman natin siya doon sa may x. So, 3, 3. So, from 2x, we have 3, 3. So, of course, 3, 3. Next, wala nang 3 dan domain. So, proceed sa 3, 2. So, 2 yung magiging domain. So, we have 2, 1. So, 3, 1. Next, 3, 1 naman. 1 yung domain. So, dalawa. 1, 3 saka 1, 2. So, 3, 3. Since may 3, 3 na tayo, no need to write. Dito tayo sa 1, 2. So, we have 3, 1, 1, 2. So, we have 3, 2. Next, proceed sa 2, 2. So, meron lang tayong 2 na domain here. So, we have 2 and then 1. Next, 2, 1. 2, 1, 1, 3. So, we have 2, 3. Also, with this one, 2, 2. Next, 1, 3. 3, 3. So, we have 1, 3. Next, so wala nang 3 na domain dito. So, proceed to 1, 2. So, ito yun. 1, 2, 2, 1. Therefore, we have 1, 1. Next, proceed here. 1, 1, 1, 3. So, we have 1 and then 3. So, since meron tayong 1, 3 kanina dito, so no need to write. So, proceed to the next. 1, 1, 1, 2. So, we have 1 and then 2.
Now let's proceed to pictorial representation of relations. Relations can be represented by any of the following: first ordered pairs, arrow diagram, table, graph, equation, and matrix. Let's have this example. Let A 1, 2, 3, B 2, 4, 6, then A times B would be 1, 2, 1, 4, 1, 6, up to 3, 6. Define the relation R as twice the first number is equal to the second number. Okay, so we have 1, 2, 2, 4, 3, 6. So that's in ordered pairs. Now, so notice 1 times 2 would be 2, 2 times 2 would be 4, 3 times 2 would be 6. Okay, and next, we can also show or represent this relation using the arrow diagram. So the first diagram would be 1, 2, 3. The second diagram would be 2, 4, 6. Then we have to put arrow to show relationship. Next, table of values. A for 1, 2, 3. So 1, 2, 3. And then table of values for 2, 4, 6. Next, we can also use equation to represent relation. B equals 2A. When A is 1, okay, as you notice here, when A is 1, 2 times 1 would be 2. Okay, so meaning we can use equation to represent relation. We can also use graph. Okay, so notice here we have points here. So 1 as our A, then 2 as our B. And the same with the other ordered pairs. Lastly, we have matrix. Okay, so we have 1, 0, 0. This matrix, it will be discussed in a higher mathematics. Okay, so that's how we're going to represent relation. Okay, that ends our session for today. Thank you for listening. God bless everyone.